Yeah, see, problems in laws of motion. So this is the problem. A constant retarding force of 50 Newton is applied to a body of mass 20 kg. Okay. Moving initially with a speed of initial speed is given 15 meter per second. How long does the body take to stop? Understood? So we have to find here how long does the body take to stop. That means time we have to find. Okay. And here the given thing or the force is given. Force applied on the constant retarding force applied on a body is 50 Newton. Okay, it is going to stop the body, right? Retarding force means it is a force which stops the body after some time. And mass of the body is given, it is 20 kg. Initially with the speed, okay, the initial speed is given, that is 15 meter per second. So by using the Newton's second law, we can write F is equal to ma. First find out what is the acceleration. A is equal to F by m. So that is 50 divided by 20. So A is equal to 2.5 meter per second square we get. Okay. Next, after finding the acceleration, we have to find the time here. So use the formula V is equal to U plus AT. Then T becomes V minus U divided by K. So the V, what is the V? Finally, the body is going to stop, right? V becomes 0 minus 15 divided by 2.5. So solve for this, you'll get 6 as the answer. Minus 6, you get the answer. But time cannot be negative, okay? So take it as a 6 second. So after 6 seconds, the body is going to stop. The next problem, this is for the homework. A constant force acting on a body of mass 3 kg changes its speed from 2 meter per second to 3 meter per second. Okay, initial to final it is given and the time is 2 seconds. The direction of the body remains unchanged. What is the magnitude and direction of the force? So the expected answer is 2.25 Newton and force acting in the direction of acceleration. Okay, solve it. This is for your homework. Yeah. There is a next problem. A driver of a car moving at 20 meters per second sees a child on the road 50 meters ahead and stops the car 10 meters earlier to the child. If the mass of the car with the driver is 1000 kg, calculate the force exerted by the brakes on the car and time taken to stop the car. Okay. First write the data, initial speed of the car 20 meter per second, and finally the car stops, right? So your final velocity becomes 0 and your the displacement. Look at there, a driver of a car moving at 20 meter per second sees a child on the road 50 meter ahead and stops the car 10 meter earlier. He's stopping the car 10 meter earlier only to the child. Okay. So that means the net displacement is 50 minus 10. It becomes 40 meter. So it traveled 40 meter distance and mass of the car is 1000 kg. Mass of the car is 1000 kg. Yeah. we have to find the time there, how much time it takes to stop. Now using the relation v square is equal to u square plus 2as. Okay, the final velocity in here, it becomes 0. This is 20 square plus 2 into a into s is 40. Therefore, 80a is equal to minus 400 it becomes. Therefore, acceleration becomes minus 5 meter per second square. Therefore, the retarding force we can calculate like this: F is equal to ma. The mass is 1000 into acceleration, and take it as a 5. So it become 5000 Newton. Retarding force. So now we have to find the time taken to stop the car. We found the F value and the A value. Use the formula V is equal to U plus 80. Finally, the car stops. This is 20, acceleration is minus 5 into T. Therefore, T is equal to 20 divided by 5. Therefore, T becomes 4 seconds. Here is your a bullet of mass 0.04 kg moving with a speed of 90 meter per second enters a heavy wooden block and is stopped after a distance of 0.6 meter. What is the average resistive force exerted by the block on the bullet? As it is the previous problem, okay, we have to solve it. What is the average resistive force? Only force we have to find. F is equal to ma. Distance is given 0.6 and here the speed is given 90 meter per second. This is the initial speed. Finally, the bullet stops. V becomes 0. Okay, you can use the formula, v square equals u square plus 2as. Find out the acceleration there and then use the F is equal to ma. So here the expected answer is minus 270 Newton. That means this is the retarding force. Okay. So this should be the answer. The next problem. A body of mass 5 kg is acted upon by two perpendicular forces. Okay. 6 Newton and 8 Newton. Mass of the body is 5 kg. It is acted upon two perpendicular forces. Let it be, this is the mass of 5 kg. Perpendicular forces, one force is acting like this and one force is acting like this perpendicularly. Calculate the magnitude and direction of the acceleration of the body. Okay, let it be the force 1. Okay, I'll take it as a F1 as a 6 Newton and here F2, this is the 8 Newton. Okay, and the angle between them now it becomes 90 degree. Got it? We have to find the magnitude and direction of the acceleration of the body. Okay, let's find out now. First, write the given mass is there 5 kg and the force is F1 6 Newton and F2 8 Newton and the angle between them, since they are perpendicular, 90 degree we can use. Okay, so the magnitude of resultant force we find first. The resultant force, the F is equal to square root of, this is the formula to find out the resultant, F1 square, F2 square plus 2 F1, F2 cos theta. Okay, since cos 90, what is the cos 90 value? It becomes 0. Therefore, F is equal to root of 6 square plus 8 square. Therefore, F is equal to, it becomes 100. Root 100 is equal to 10 Newton. This is the force. And find out the acceleration. The acceleration A is equal to F by M from the Newton's second law. F is equal to ma. We can write this 10 divided by 5, mass is 5 kg. So we get 2 meter per second square. Okay. Now we have to find the direction. What is the direction of acceleration? That means the theta you find. Okay. So the theta is equal to tan inverse of F1 divided by F2. Therefore, theta is equal to tan inverse of 6 by 8. So it becomes tan inverse of 0.75. Yeah. After solving the tan inverse of 0.75, we get 36 degree 52 minute. This is with F1. That means the acceleration somewhere it goes like this, okay, with 36 degree in this direction with the angle 36 degree 52 minute with F1. Next problem is on the collision. A car of mass 1000 kg moving 1000 kg is given, moving with a speed of 30 meter per second, collides with the back of the stationary lorry. Observe the stationary lorry means the lorry is at rest of mass 9000 kg. Car mass is 1000, lorry mass is 9000 kg. Calculate the speed of the vehicles immediately after collision. If they remain jammed together means after collision, so both will attach each other. Okay, this is the car A having the mass m1, okay, and having the speed u1. Let it be. This is 30 meter per second, and the mass it is 1000 kg, and this is the stationary lorry. So lorry mass is 9000 kg and its velocity initially it is 0, no? Initial speed is 0. So after colliding, it will come and hit the lorry. Both the masses will combine together. So A and B both will combine. So the masses will be added. M1 and M2 both stick together. And now we have to find what is the final velocity of the together masses. Okay. So use the law of conservation of momentum. From law of conservation of momentum. M1 U1, the momentum before collision, right? The total momentum before collision is equal to total momentum after collision. M1 plus M2 into V. The M1 is 1000 into U1 is 30. M2 9000. U2 is just 0. M1 plus M2. 1000 plus 9000. Totally it becomes 10,000 into V. Okay. Here this term completely it becomes 0, right? And here 30 into 1000, 30,000 it becomes 30,000 divided by 10,000. That is the V. Therefore, V becomes 3 meter per second. Okay, this is the velocity uh, of the speed of the vehicles immediately after collision when they jam together. Yeah, there's the next problem again based on the collision part. A grenade of mass 15 kg, grenade mass of 15 kg, moving at 10 meter per second, breaks into two parts. The one part moves in the original direction. Okay, it goes straight. It is at the one part after collision, after blasting. It moves in a one direction. The one part. Okay, let it be on mass A. Okay, it moves with 18 meter per second, and other part moves in the opposite direction. Okay, exactly opposite direction like this. Let it be the mass B, and it is moving at 16 meter per second. This is the same grenade only. After blasting, the pieces move like this. Calculate the masses of the two parts. Okay, what are the masses? This is a M1, and let it be this is M2. And initial mass of the grenade is 15 kg. This is of 15 kg. Let the M1 be just M. Okay, I'm taking just as a M. And M2 becomes, what will be the M2 becomes? Then it becomes 15 minus M, right? Initially 15 kg. Out of that, this M is bent, right? The M1 is came there. And the left out mass is 15 minus M. That will be towards the B. And you can take this one as a V1, the velocity, and this is the V2. Since it is moving in opposite direction, I can take it as a negative, minus 16 meter per second. V2 value, yes, 6 meter per second it is, not the 16. Make it correct. This is 6 meter per second. Okay. Now use the law of conservation of momentum. According to that law of conservation of momentum, initial momentum, right? So initial mass moving at 10 meter per second it is. Correct now. The initial momentum is equal to final momentum. So M into capital M into 10 is equal to the final momentum M1 into 18 plus the second M2 into minus 6. So capital M is the 15, 15 into 10. M1, I'm just taking as a M only, into 18, and M2, 15 minus M into minus 6. Solve this one, you get 150, 18M. Multiply this, minus into minus plus 6M. Solve this one, 150 plus 90 becomes, that is 240. is equal to 24 m. Therefore, m is equal to 240 divided by 24, right? So I'm getting m as a 10 kg. What is this m? Since m is nothing but the m1, right? Therefore, m1 is the 10 kg and m2 is 15 minus m. That is 15 minus 10. It becomes 5 kg. This is the m. Take this one as a homework. A machine gun of 15 kg fires 0.02 kg bullets at the rate of 10 per second. Okay, per second, 10 bullets will come out from the gun, and each bullet carries the weight of 0.02 kg, and it is moving at a speed of 300 meter per second. Calculate the force required to hold the gun in position. Okay, use this formula given the hint, find out the velocity from this. Okay, so here you can take, so this is the mass of the bullet. You can take the capital M, mass of the gun it is. Okay, mass of the gun, and small m is the mass of the bullet, and find out the B value. You get this. Then use the formula V is equal to U plus AT, find out the acceleration, and then use the formula F equal to MA, you will get 60 Newton. So this is the force required to hold the gun. This is the problem. An aircraft executes a horizontal loop at a speed of 720 km per hour with its wings banked at 15 degree. What is the radius of the loop? So the velocity is 720 kilometer per hour. 720, okay, convert into meter per second, 3600. So it becomes 200 meter per second. It is executing a horizontal loop. Okay. So what is the normal force on the wings? So the normal force on the wings, according to the vector resolution, the n cos theta will be acting towards the mg, and n sin theta will be balanced by the centripetal force. Okay, that is mv square divided by r. Okay, equation 1 and equation 2. We have derived this. Okay, so when a car taking a curve, okay, on the road, so based on that concept, there is a wing, the loop, it is creating a loop. Okay, so like n cos theta, and here is a mg, and here is a n sin theta, right? And it is balanced with the centripetal force, mv square by r. So it is creating the loop. So divide the equation 2 by 1. On dividing equation 2 divided by 1, then you get sine theta by cos theta as a tan theta is equal to, mass terms will be get cancelled, v square divided by rg we get. Therefore, they're asking what is the radius of the loop. Take the r as a v square divided by Rg tan theta. Therefore, R is equal to, this is 200 square V square by G tan theta. It is, the G is 9.8 into tan 15 degree. Okay. Substitute and calculate. Calculate this. 200 square divided by 9.8 into tan 15 degree. What is the value for tan 15? Tan 15 degrees, 0.2679. Substitute 0.2679 and you get 15232 meter. So in another word, we can tell in terms of the kilometer that 15.23 kilometer. So this is the radius of the loop made by the aircraft. Yeah, here is the problem. A stone of mass 250 gram, okay, mass is given 250 gram, is tied to the end of a string, is wheeled in a circle of the radius 1.5 meter. Okay, it is creating a circle of radius 1.5 meter with a speed of 40 rotation per minute. Okay, per minute is that is a speed. That means it is a frequency it is given. Okay, 40 rotation RPM, rotation per minute. So convert into rotation per second, 40 by 60 RPS, rotation per second. In a horizontal plane, what is the maximum speed with which the stone can be wheeled around the string, can withstand a maximum tension of 200 Newton? Okay, maximum tension, T maximum, right? It is 200 Newton. Yeah, what is the maximum speed it can withstand? The maximum speed we have to find. Okay. Yeah. Let's find out now. First, what are the things we required here? Hmm, T is equal to centripetal force we can use since it is wheeling in a circular path. So the tension in a thread, okay, is balanced by the centripetal force mv square divided by r. This you can take it as a V maximum. Therefore, V maximum is equal to root of R into T divided by M. So that is equal to root of the R, 0.5 into tension in the thread. We can take that 200 whole divided by the mass. Okay, 250 gram it is. Convert in terms of kg, it will become 0.25 kg. 0.25 kg. Therefore, V maximum is equal to, solve for this, you will get 34.64 meter per second. 34.64 meter per second. So this is the maximum speed of the stone.